18 miles of ice. Under it, an ocean holding twice as much water as every sea on Earth, and someday we will live inside it. Down there waits water that never sees the sun, ice spikes as tall as a house, snow that falls upward, and a sky so radioactive it could kill you in a single day. If this journey grips you, drop a like and subscribe. Take a deep breath. We begin the descent. Stand on Europa for one full day and you are already dead. Your boots touch ice as hard as granite. The gauge on your wrist reads 260 degrees below zero. Above you hangs Jupiter, filling a quarter of the sky, striped orange and cream, so enormous your brain refuses to accept it. The ice runs flat and white to the edge of sight. Silence sits on everything, and something is pouring through your body right now. You cannot see it. You cannot feel it. Jupiter spins fast, and inside that spin lives a magnetic field so powerful it dwarfs everything in the solar system, except the sun itself. That field grabs loose electrons and protons and whips them around the planet at nearly the speed of light. It builds a donut of screaming particles, invisible, thousands of miles across. Europa orbits inside the donut. Every second you stand there, those particles slam into your suit. They pass through the fabric. They pass through your skin. They knock electrons off the molecules inside your cells and rip your DNA into pieces. The number is 540 rem a day. Put that next to a chest X-ray. One chest X-ray gives you a tiny tickle of radiation. Europa's surface hands you roughly 50,000 of them in 24 hours. A nuclear plant worker on Earth is legally allowed 5 rem in an entire year. Europa gives you more than a century of that limit before lunch. The first hour, you feel fine. By the end of the day, your stomach turns and your mouth fills with the taste of metal. Within a week, your bone marrow quits making blood. Doctors have nothing for this. There is no coming back. This is why the engineers building Europa Clipper wrapped its brain in a vault. A box of titanium and aluminum, walls thick as your thumb, built for one job. Keep the electronics alive long enough to matter. Even with the vault, the spacecraft will refuse to orbit Europa. It will swing past, fast, again and again, close to 50 times, like a person sprinting through a burning room and back out to breathe. Machines get a vault. You get something better. You get water. Radiation dies in water. Every foot of ice you stack between yourself and that sky cuts the danger down. 6 feet helps. 60 feet helps more. A few 100 feet, and the storm above becomes a rumor you tell your kids. So the plan writes itself. Any human on Europa lives underground. Picture the routine. You suit up in a chamber cut from ice. You climb a shaft. You get maybe 40 minutes on the surface before your dose meter starts screaming in your ear. You plant a sensor. You check a cable. You look up at Jupiter once, because everyone does, and then you go back down. Nobody on Europa gets a sunrise. Nobody on Europa gets a walk. The surface becomes a place you visit in armor. Quickly, rarely, with a countdown running. Home is down. Which leaves one question standing, and it is the only one that decides whether any of this is possible. How far down? For 40 years nobody knew. The guesses ran from a couple of miles to dozens. Half the scientists pictured a thin skin you could punch a hole through in a season. The other half pictured a wall. Then a spacecraft listened to Europa glow, and the answer landed like a hammer. Ice does not sit there quietly. It shines, not in light your eyes can catch. Ice gives off a faint microwave hum, and the pitch of that hum depends on how warm the ice is. Cold ice hums one way, warmer ice hums another. And here is the trick that cracked Europa open. Different microwave frequencies climb out from different depths. The high notes come from the top few yards. The low notes come from miles down. In September of 2022, the Juno spacecraft swung past Europa at a distance of 220 miles. Moving so fast the whole encounter lasted minutes. On board sat an instrument built to stare at Jupiter's clouds. Somebody pointed it at the moon instead. It listened to 6 frequencies at once. Then a team spent 3 years turning that hum into a temperature chart. Warm at the bottom, cold at the top, a smooth slope running down through the shell. They followed the slope until it crossed the line where ice has to become water. That crossing point is the floor of the sky and the ceiling of the ocean. The answer, published in early 2026, about 18 miles. Sit with that shape for a second. The deepest hole humans have ever drilled on Earth is a Russian borehole in the Arctic. 20 years of work, It reached about 7.5 miles, and then the rock got too hot and soft and they gave up. Europa's roof is more than twice that, and it is not rock. It is ice as hard as granite, at temperatures that shatter steel. Stack Mount Everest 3 times over. That is the ceiling. There is a margin on the number, roughly 6 miles either way, so the ice might be 12 or it might be 24. Salt in the shell would shave a few miles off. Either way, the argument is finished. Europa does not have a thin skin. For the people hunting life, this landed badly. The whole dream ran on a simple pipeline. Radiation smashes water on the surface into oxygen. The oxygen sinks, the ocean breathes, life eats. A thin shell makes that pipeline short. An 18-mile shell makes it a marathon. The same Juno readings found something else. The upper ice is full of tiny flaws. Cracks, pores, bubbles, none of them bigger than a few inches across, scattering microwaves the way a cloudy ice cube scatters light. They reach down hundreds of feet in a shell of 95,000 feet, which means those flaws stop far short of anywhere useful. The team said it plainly. The fractures we can see on Europa's face are, on their own, too small and too shallow to carry food down to the ocean, so the roof is thick and it may also be sealed. For a colonist, though, that same wall is the best news in the solar system. 18 miles of ice is armour no engineer could ever build. Every particle Jupiter throws dies somewhere in the top few yards. Down at the bottom, the radiation reads 0. You could walk around in a t-shirt if the water were not trying to freeze you. Your killer roof is also your fortress. The problem is getting through it. And before you drill a single foot, you have to land. Which brings up something a team of geologists worked out in 2018. Something that could destroy your lander before the engines even shut off. High in the Andes, above 13,000 feet, the snow grows teeth. Hikers call them penitentes, fields of ice blades waist high, chest high, all leaning the same direction, all pointed at the noon sun. Charles Darwin ran into a field of them in the 1830s and could not explain them. They form when sunlight digs pits into ice, while the ridges between the pits stay cold and dry. The pits deepen, the ridges sharpen. Given a season, you get knives. Now hand that process 50 million years. That is what a team at Cardiff University did in 2018. They ran the numbers for Europa's equator, where the sun sits high overhead and the ice slowly turns straight from solid into vapour. They checked whether Jupiter's particle storm would sand the blades back down. Below 23 degrees of latitude, the ice carves itself faster than the radiation erodes it. So the blades win. They grow at roughly 1 foot every million years, which is the slowest construction project imaginable. And Europa's surface has sat mostly untouched for about 50 million years. Do the arithmetic and you get spikes 50 feet tall, standing about 25 feet apart across a belt that wraps the entire equator. 50 feet is a 5-story building. Picture a city block of 5-story buildings ground to razor points, packed shoulder to shoulder in the dark at 300 degrees below zero. The team found supporting evidence hiding in old data. Europa's equator swallows radar in a way nobody could explain. The signal goes in and it barely comes back, which is exactly what happens in a recording studio where they hang foam wedges on the walls to trap sound. Europa's midsection behaves like an acoustic wall the size of a continent. Wedges, pointed wedges. The danger here is subtle. A spike will not skewer your lander. Your lander weighs almost nothing in this gravity, and it comes down slow. The kill is the gap. Between every pair of blades sits a pit, dark and narrow and deep, and if one leg finds a pit while the other 3 find ridges, your $1 billion machine tips over and dies pointing at nothing. Probes have done this before. Landers on comets have bounced and flipped and wedged themselves in cracks like beetles on their backs. Not everyone buys it. A glaciologist writing in 2023 pushed back hard. On Earth, he argued, penitentes need melting to work. Liquid water has to run in the troughs. Europa is far too cold for anything to melt. The formation story simply does not transfer. He also pointed out that Europa reflects light like a bright flat mirror, which is the opposite of what a forest of light-trapping blades should do. The honest answer today? Nobody has seen them. Our best photographs of Europa came from Galileo in the 1990s, and they are too blurry to show anything smaller than a football stadium. The blades sit under the resolution limit, real or imaginary, waiting. Europa Clipper carries a camera that will settle it. Starting in 2031, on the first close pass, we will finally see the ground at human scale. Until then, mission planners aim for the poles and for young terrain, where the ice has not had time to grow its teeth, which is strange when you think about what Europa looks like from far away. Because from a distance, this moon is the smoothest thing in the entire solar system, and that smoothness is not a comfort, it is a warning. Look at our moon and you are looking at a war record. Craters on craters, rims inside rims, 4 billion years of rocks arriving at 40,000 miles an hour, every impact preserved forever because nothing up there erases anything. Same on Mercury, same on Callisto, out at the edge of Jupiter's family so cratered its surface has run out of room for new ones. Now look at Europa. It is almost blank. Scientists have counted the craters on Europa and the number is embarrassing. 24 or so of any real size, on a world that has been sitting in the same shooting gallery for 4.5 billion years. The mountains are missing too. Europa has no peaks worth the name. Take this moon and shrink it down to the size of a bowling ball, and it would be smoother than the bowling ball. Run your hand across it and you would feel a few scratches and nothing else. It is the smoothest solid object we have ever found. Something is erasing the evidence. Count the craters carefully and you can date a surface, because impacts arrive at a rough and steady rate. Do that for Europa and you get an answer between 50 and 90 million years old. Europa is 4.5 billion years old, wearing a face that is younger than the last dinosaurs. Imagine a woman in her 90s with the skin of a toddler. Something in her is replacing it constantly from underneath. That is the tell. That is how we knew about the ocean before we ever measured it. A dead world keeps its scars. A world that erases them has something moving beneath the skin. And on Europa, that something is water. The ice shell floats on it. The shell cracks. Warm ice pushes up through the wound, spreads out and freezes flat. New ground, old craters gone. The whole moon repaves itself, the way Earth's ocean floor gets born at the mid-ocean ridges and swallowed at the trenches. Europa runs the same machine, built out of ice instead of rock, which tells you something uncomfortable about the place you want to live. The ceiling above your habitat is not permanent. It is a conveyor belt. Given enough time, every square foot of ice on Europa gets torn up, dragged sideways, shoved down, and remade. 50 million years for a full cycle sounds like forever. Compared to a human life, it is. Compared to a colony that plans to last, it is a countdown. And the erasing is not gentle or steady. It happens in fits. A section of shell holds for ages and then goes all at once. There is one more clue in that blank face. Whatever resurfaces Europa needs energy, and the sun is useless out there. At 5 times Earth's distance, sunlight arrives at about 1/25 the strength. A world that far out and that small should have frozen solid down to the core billions of years ago, the way Callisto did. Europa refused. So something is feeding it heat from inside. Something enormous. Something that has been running without pause since before the Earth had continents. We will get to what that something is, and to the way it makes the entire moon breathe. First, you have to get inside. And the machine that takes you there works by melting a tunnel that seals shut behind you. In 2012, a Russian drilling team finally punched through to Lake Vostok. It sits in Antarctica, buried under 2.5 miles of ice. A lake the size of Lake Ontario that has been sealed off from the sky for 15 million years. Getting there took 23 years of work, a drill rig the size of a house, and thousands of tons of kerosene poured into the hole to stop it from freezing shut. 2.5 miles, 23 years. Europa's ice is 18 miles thick and you cannot bring a rig. So the plan changes shape entirely. You do not drill Europa, you melt it. The machine is called a cryobot. Picture a metal cylinder about the size of a telephone pole with a hot nose. Inside sits a small nuclear power source, a lump of plutonium giving off heat the way a coal gives off heat, steadily for decades, with no moving parts to break. You set it on the ice and switch it on. The nose warms, the ice under it turns to water. The machine sinks. It is a hot knife through butter, except the butter closes behind you. The water above the cryobot refreezes almost instantly, because the ice around it is hundreds of degrees below zero in Hungary. The tunnel disappears. Your machine is sealed inside a moon moving down through solid ice at a few feet an hour, dragging a hair-thin fibre-optic tether behind it as its only voice. That tether is the whole mission. Radio cannot claw its way through 18 miles of ice. Cut the fibre, and your probe becomes a very expensive secret. Run the math on the descent and the number gets ugly. Even at a generous pace, 18 miles takes years, and the ice fights back at every level. Near the top, it behaves like brittle rock and cracks instead of melting. Deeper down, it starts to flow like extremely slow honey, and the pressure squeezes your tunnel closed around the machine's waist. Pockets of salt turn up and change the melting point without warning. Boulders of harder ice sit waiting to knock the probe off course. Now put a person in that picture. You do not ride a cryobot. A human shaft into Europa looks like a construction project measured in decades. Melt a bore. Line it with structure so the ice cannot squeeze it shut. Fill it. Pressurize it. Build the elevator. Build the elevator again when the shell shifts and shears your first one in half. Every colony on Europa hangs from a single thread going up to the surface, and the moon is actively trying to cut it. Nobody has done this. NASA has studied cryobots for years and tested pieces of them in glaciers. A lab in California built a small submarine called Brewy that drives upside down along the underside of Antarctic ice, tires on the ceiling, hunting for the exact spot where microbes gather. These are rehearsals for a play we have never staged. But say it works. Say the nose finally breaks through after all those years of dark. There is a moment, one moment, when the last inch of ice gives way and the probe's lights swing down into water no sunlight has touched in 4 billion years. What is down there is not what you are picturing. Your lamp comes on and finds nothing. That is the first shock. On Earth, you turn on a light underwater and the beam hits something. Sand, a wall, a fish, a cloud of silt. On Europa, the beam goes out and keeps going and dies of exhaustion. There is water in every direction and there is nothing in it to bounce off. You look up instead, because up is the only place with a surface, the ceiling. It runs away from you in every direction, flat and pale and endless, the underside of 18 miles of ice. It is your sky now. It has ridges and cracks and shallow domes. It has colour, faint browns and yellows where salt is soaked in. And it never ends, because Europa's ice shell is one single unbroken skin wrapped around an entire world. Then you look down and you understand the real problem. Europa's ocean is between 40 and 100 miles deep. Earth's ocean averages about 2 miles. Our deepest point, the Mariana Trench, reaches nearly 7, and only a handful of humans have ever gone there. Europa's ocean starts where our deepest trench ends, and then continues for another 90 miles. This moon is smaller than our moon. It's about the width of the drive from New York to Los Angeles, and you could fit 4 of them inside Earth. Yet it holds more than twice the water of every ocean, sea, lake, river and puddle on our entire planet combined. All of it in the dark. All of it at once. Stand at the bottom of your access shaft and you're standing at the top of the deepest body of water in the solar system, and the floor is 60 miles below your feet, and no light has ever reached it. There is no horizon down there, because horizons need a surface and a sky. There is no up and down that your body trusts, because everything looks the same in every direction. Divers on Earth get lost in that feeling in a swimming pool at night. Europa serves it to you across 100 million square miles, which means every human structure on Europa hangs. You do not build on the seafloor. The seafloor is 60 miles down, at pressures no submarine has ever faced, and getting there is a whole separate expedition. You build against the ceiling. Your habitat clings to the underside of the ice like a barnacle on a hull, upside down, anchored into the roof with bolts driven into frozen granite. Your world is a bubble stuck to the bottom of a sky. The water outside sits right around freezing, held liquid by pressure and salt. It is dark, it is cold, and it is moving. Not violently, slowly, patiently, in currents no wind ever pushed. There is one mercy in all of this, and it is the strangest gift Europa gives you. The moment your feet leave the shaft floor, you weigh almost nothing. Step off the ladder, and something is wrong with your body. Europa's gravity runs at about 1/8 of Earth's. Take a person who weighs 150 pounds at home. On Europa, the scale reads 20 pounds, about the weight of a car tyre. That is you, everything you are, standing on ice. Your muscles have spent your whole life fighting a planet. They were built to push 150 pounds up a flight of stairs. Now they push 20, and the first thing that happens is you launch yourself into the ceiling. Every colonist does it. Every single one. You lean forward to take a normal step and you sail 8 feet. You reach for a shelf and overshoot it by a foot. You set down a crate and it drifts. New arrivals wear helmets indoors for a month, and it is not a joke. Falling is the part that breaks your brain. On Earth, you trip and you hit the ground in half a second. It is over before you can think. On Europa, you trip and you have time. You have almost 2 full seconds to watch the floor come at you, arms turning, mind racing, and there is nothing you can do about it because you have no weight to push against. Then you land gently like a leaf. In the water, it gets stranger. A human body is mostly water, so a human body is nearly neutral in the ocean anyway. You float on Earth already. Europa's weak gravity means the whole business of sinking and rising, which shapes every second of diving on our planet, more or less stops. Drop a wrench in Europa's ocean and it goes down, but it goes down like a feather falling through syrup. You can watch it for a minute. You can swim after it and catch it. Divers on Earth carry weight belts and fight buoyancy constantly. On Europa, you drift. You push off the habitat wall with 2 fingers and you cross a room. Currents matter more than swimming, because your kick barely beats them. Building things becomes almost comical. 2 people move a steel beam that would need a crane at home. A child could carry a refrigerator. Ceilings go up high, because why not? And stairs disappear, because you jump. Then there is the pressure question, and here Europa is oddly kind. At the bottom of 18 miles of ice, the weight of everything above you is pressing down. On Earth, 18 miles of anything would crush you into paste. Europa's gravity is so weak that the same column of ice presses with roughly 1/8 the force. The pressure at your habitat runs somewhere near what a deep submarine handles on Earth. Serious, survivable, engineerable. Weak gravity is why the ceiling does not crush you. Weak gravity is why you can move a beam alone. Weak gravity is why Europa is possible at all. It reads like a gift. It is a bill. Your body has spent 400 million years of evolution assuming a planet would pull on it. Take that pull away for a year, and it begins tearing itself apart in ways that have nothing to do with the ice, the cold, or the dark. Bone is alive and bone is lazy. Every day your skeleton runs 2 crews. One crew tears old bone out. The other crew builds new bone in. The building crew takes its orders from pressure. Walk, and your leg bones bend a hair, and the cells feel it, and they lay down fresh material where the load lives. Sit still, and they stop. Your skeleton is not a frame. It is a negotiation with gravity renewed every single day. Take the gravity away and one crew keeps working while the other clocks out. We know what happens because we have watched it happen. Astronauts on the space station lose roughly 1 to 2% of the bone in their hips and spine every month. 6 months up there cost you what an elderly woman loses in a decade of aging. Now stretch that across a colony. A 5-year rotation under Europa's ice is 60 months. Even if 1/8 of a gravity slows the loss, the arithmetic bites. You come home with a spine that belongs to someone 30 years older. You step off the ship on Earth and your own weight, the weight you carried your entire childhood, breaks your hip in the airlock. The muscles go first and go faster. Your calves and your back exist to hold you up against a planet. Give them nothing to hold and they shrink within weeks. Astronauts strap themselves to machines for 2 hours a day, every day, forever, just to slow it down. That is not fitness. That is maintenance on a machine that is disassembling itself. Your heart is a muscle too. On Earth it spends every beat shoving blood uphill to your brain. On Europa, uphill barely exists, so the heart eases off and gets smaller, and the walls thin out. Then the fluids move. On Earth, gravity keeps about a gallon of your blood and water pooled in your legs. Remove it, and all of that surges into your chest and head. Astronauts call it puffy face and chicken legs, and it looks funny in photographs. It is not funny in your skull. The pressure pushes on the back of the eyeball and flattens it. It swells the optic nerve. A serious number of long-duration astronauts come home with permanently damaged vision, and nobody has fixed it. Here is the part that should frighten you. Every number in this chapter comes from 0 gravity or from Earth. We have data at 1 gravity, and we have data at nothing. Europa sits at 1/8. There is no third data point, not one. Nobody has ever measured what a human body does at low gravity for a long time, because nobody has ever lived anywhere except a planet and a floating tin can. We do not know whether 1/8 is enough to keep bone alive. We do not know if a child conceived on Europa can grow a skeleton that works. We do not know whether that child could ever visit Earth without a wheelchair. A colony on Europa is a medical experiment with the humans already inside it, and they run that experiment in the strangest room ever built. Because on Europa, the sky above your head has been nailed in place since before life on Earth began. Europa has one face, and it stares at Jupiter forever. Jupiter's gravity got hold of this moon billions of years ago and slowed its spin until the rotation matched the orbit exactly. Astronomers call it tidal locking, and it is the same trick our moon plays on us. One side of our moon has faced Earth since before there were fish. The far side stayed a total mystery until a Soviet probe went and looked in 1959. Europa does the same thing to Jupiter, which produces a sky that makes no sense. Stand on the Jupiter-facing side and the planet hangs there, 24 times wider than the moon looks from your backyard, taking up a quarter of everything above you. It has bands, it has storms bigger than Earth, it has a red spot you could drop our whole planet into, and it does not move. Not at dawn, not at midnight, not next year, not next century. It sits at the exact same spot in the sky, hour after hour, wobbling by a few degrees and nothing more. Walk 100 miles in any direction and it shifts a little, like a mountain does when you drive past. Stay put, and it is nailed down. Sailors navigated Earth for thousands of years using a sky that turned. Europa gives you a signpost welded to the ceiling. You could never get lost. You could also never feel time pass by looking up. Walk far enough around this moon and Jupiter sinks and vanishes, and the sky on the far side is just stars and a small bright sun. 2 hemispheres, 2 completely different lives, and no way to see both at once. Here is the cruelty. You will never see any of it. Your home is 18 miles under the ice, the greatest view in the solar system, the single most spectacular sight a human being could ever stand under, is on the other side of a wall of frozen granite 3 times the height of Everest. You get it on a screen. Somewhere on the surface, a camera in a lead box takes pictures of Jupiter and pipes them down a cable, and they play on a monitor in the mess hall. That is your sky. A rectangle. Refreshing every few seconds, showing a planet that never changes. Think about what that does to a person over years. The human brain hunts for change. It is why we watch fires. It is why we watch waves. Take a species built to scan the horizon and put it in a metal room with no horizon, no weather, no seasons, no sunrise, and one photograph of a giant that never blinks. Antarctic winter crews go strange after 4 months, and they at least get a blizzard. There is a deeper problem hiding in that frozen sky, and it has to do with time itself. On Earth, a day means something. Light comes, light goes, and your body follows without asking permission. Every cell in you runs on a 24-hour rhythm that came from a spinning planet. Europa does not spin like that. So what exactly is a day when your sun is a dot and your sky is a photograph? Europa goes around Jupiter in 3.5 Earth days. Since it is locked, that orbit is also its day. Sunrise to sunrise takes about 85 hours. 42 hours of light. 42 hours of dark. Except calling it light is generous. Out at Jupiter's distance, the sun is 5 times farther away than it is from your window. Light spreads as it travels, and it thins out fast, so Europa gets about 1/25 of the sunlight Earth does. The sun in Europa's sky is a brilliant point, painfully bright to look at and far too small to be a disk. Full noon on Europa is roughly as bright as the moment right after sunset on Earth. That dim blue hour when the streetlights click on, that is high noon. That is as good as it gets, forever. The temperature never comes to your rescue either. The equator sits at 260 below. The poles reach 370 below. Ice at those temperatures is not slippery and it is not soft. It behaves like rock. Hit it with a hammer and it rings. Now bring all of that down the shaft where none of it reaches you anyway. Under the ice there is no light at all, 0. The distinction between noon and midnight is a number on a clock and nothing else. So a colony has to build time from scratch. Every human being carries a clock in the brain about the size of a grain of rice. It runs a rhythm close to 24 hours, and it needs light to stay honest. Deny it light, and it drifts. Volunteers who have lived in caves for months without a watch settle into strange cycles, sleeping 25, 28, 30 hours at a stretch and losing all sense of what day it is. Some of them lost weeks. Underground on Europa, you would run on manufactured dawn, lights that brighten on a schedule and pretend to be a sun. Bright and blue in the morning, warm and orange at night, because your brain reads colour the way a sailor reads the sky. The question the colony has to answer on day one is which clock to keep. 24 hours makes no sense here. Nothing outside matches it. It is a habit imported from a planet nobody in the room can see. 85 hours is what Europa actually offers, and no human being can sleep through 42 hours of night. So you invent something. Maybe a 24-hour rhythm inside a moon that does not care. Maybe something new. Whichever you choose, it is a decision, made by a committee and enforced by lights. Time on Europa is a policy, and once you build a fake day, you notice that the moon does have a real rhythm. It has a pulse. Slow, powerful, absolutely regular. Every 3.5 days, Europa gets squeezed. Not gently. The entire moon changes shape. The ice over your head rises and then it drops, and it has been doing it since before Earth had oxygen. Your ceiling is breathing. Europa's orbit is not a perfect circle. It is slightly stretched. That one small imperfection is the reason you're alive down there. A perfect circle would keep Europa the same distance from Jupiter forever, and Jupiter's pull would be steady and nothing would happen. The stretch ruins the peace. On one part of the orbit, Europa swings closer and Jupiter's grip tightens. On the other part, it drifts away and the grip eases. Gravity pulls hardest on whatever is nearest. So the side of Europa facing Jupiter feels more pull than the far side, and the moon stretches into a slight egg pointing at the planet. As Europa moves nearer and then farther, the egg gets fatter and then thinner, over and over, every 3.5 days. Take a paperclip and bend it back and forth. Now touch it. It is hot. You did not add any fire. You just moved the metal against itself, and the friction inside it turned motion into heat. Europa is the paperclip. Jupiter is the hand. The ice shell above your habitat rises and falls by around 100 feet on every cycle. 100 feet straight up and back down, across a slab as big as a world. The tide on Europa is not the water. It is the ceiling. That flexing does something no other force out there could manage. It keeps an ocean liquid 5 times farther from the sun than we are, on a moon smaller than our own, in a place that should have frozen through to the core 3 billion years ago. Callisto, further out, did freeze. It sits there cratered and cold and finished. Europa refused because Jupiter never stopped squeezing it. There is a second player in this, and it is the part that gives the whole thing its permanence. Europa is caught in a rhythm with its neighbours. For every one orbit Ganymede makes, Europa makes 2, and Io makes 4. Locked, exactly, like gears in a watch. Every few days, the same moons line up in the same places and tug on each other in the same direction, and that repeated tug keeps stretching Europa's orbit back out. Without it, the flexing would have smoothed the orbit into a circle long ago, and Europa would be a dead ice ball. Instead, 3 moons hold each other in a grip that has run for billions of years and will run for billions more. You can see the extreme version one door down. Io, the innermost of the 3, gets flexed so violently that its whole body churns with magma. It has 400 volcanoes. It throws sulfur 200 miles into space. It is the most volcanic object in the solar system, and it is being tortured by the exact same mechanism that keeps your ocean warm. Europa got the gentler dose. Enough for water, not enough for fire, probably. Sit in a habitat bolted to that ceiling and you can feel it. 100-foot heave, twice a cycle. So slow you would call it a mood rather than a movement. Instruments catch it easily. Your inner ear catches it too. The moon inhales, the moon exhales. And ice does not bend 100 feet without consequences. Every 3.5 days, all that stress has to go somewhere. It goes into breaking. In Antarctica, researchers who leave microphones on the ice come back to recordings that sound haunted. The shelf groans. It cracks like a rifle. It sings in long falling notes as a fracture races through it, faster than sound travels in air. Nobody is there. The ice is doing it to itself. That shelf is a few 100 feet thick, and the forces working on it are small. Europa's shelf is 18 miles thick, and the force working on it is a planet. Ice at 300 degrees below zero has no give. It cannot bend and shrug the way warm ice does. It holds and holds and holds, and then it fails all at once, and the failure runs. So every orbit, as the shell heaves up and settles back, the top of it snaps. Not in one place, everywhere, constantly. Europa is a world in a permanent state of quiet fracture, and it has been for longer than there have been cells on Earth. You would hear it before you felt it. Sound travels through ice about 4 times faster than through air, and it travels far because there is nothing in solid ice to absorb it. A crack forming 100 miles away arrives at your habitat as a click. A big one arrives as a boom that runs through the walls, through the floor, through your ribs. Colonists would learn the vocabulary within a week. The little pops all night, like a house settling, except the house is a moon. The long grinding notes when 2 sections of shell slide past each other, and every so often, the one that stops every conversation in the room. There is a reason to love the noise, though. Sound is a probe. Send a wave into ice and it comes back changed, and the change tells you what it passed through. Geologists on Earth read entire mountain ranges this way, and they never lift a shovel. A network of listening stations frozen into Europa's shell would map the fractures overhead in real time. It would watch a crack grow for weeks before it reached you. It would give you a warning. It might also give you the ocean's shape. Sound crossing 100 miles of black water and bouncing off a seafloor no one has seen would draw a picture of the bottom of the Europa. The first map of a world's floor made of echoes. The danger is honest and simple. Your habitat is bolted to a ceiling that is actively tearing. Every anchor point sits in ice under stress. The shell moves slowly, and it does not consult you. Structures on Europa are designed to flex, to be re-anchored, and to be abandoned. There are also stories in that ice. Fracture leaves patterns, and the patterns record which way the moon was being pulled when they formed. Read them carefully and you can read Europa's history. Some scientists think the patterns show the ice shell rotating slightly faster than the rock underneath it, sliding around the moon like a loose skin on an orange, one full lap every 10,000 years or so. Your whole world drifting sideways forever. Most of that stress ends up in the same places. It gathers, it concentrates, and it carves. Which is why, from space, Europa looks like a cracked egg. Those cracks are the biggest features on the moon, some of them 12 miles across, wrapping the entire globe. And to a colonist, they're either the road system or the worst possible place to be standing. The first photographs of Europa came back in 1979, and everyone said the same thing. It looks like a cracked egg. Dark lines run across the whole moon. They cross each other. They curve. They stretch for thousands of miles, unbroken, over a surface with no mountains to interrupt them. Scientists named them lineae, which is Latin for lines, because nobody had any idea what else to call them. The big ones run more than 12 miles wide. 12 miles across is the width of a city. Picture a scar the width of Manhattan and its rivers, running from Boston to Miami, and then continuing past the edge of the map and around the planet and back to where it started. Get closer, and the structure appears. A dark, fuzzy edge on either side. Ridges running down the length like tire tracks, and down the middle, a stripe of paler, fresher material. That middle stripe is the giveaway. Earth has the same pattern at the bottom of the Atlantic. A ridge runs down the middle of the ocean, the seafloor pulls apart, magma wells up into the gap and freezes, and every year the Americas and Europe drift a little further apart. The new rock in the middle is the youngest thing on the ocean floor, and it gets older the further out you go. Europa runs that machine with ice. The shell pulls apart. The gap opens. Warmer, softer ice from below squeezes up into the wound and spreads sideways and freezes. Fresh material in the centre. Older material shoved outward. Nobody has to guess about this because you can look at the pattern on either side of a linear and slide them back together and they match, the way a torn photograph matches. Look closer still and you find the cracks have moved sideways too, one side dragging past the other, exactly like the San Andreas Fault in California. Europa has faults. Europa has spreading centres. Europa has plate tectonics built out of frozen water. Now stand on the ceiling underneath one. A colonist looks up at a linear and sees a seam. Fresh ice. Young ice. Ice that came from somewhere below, which makes it the thinnest and weakest part of your roof and also the most interesting. Because a crack is a door. Every argument about life on Europa comes down to whether stuff can travel between the surface and the ocean. The surface has oxygen. The ocean has water and warmth. Keep them apart and Europa is a sealed bottle. Connect them and you have a living system. Lineae look like the connection. Wide open wounds in the shell, thousands of them, reaching down. So a colony would build along them. Your access shaft goes up through fresh ice instead of 18 miles of granite. Your monitoring stations sit in the seam. You would go where the moon has already done the drilling. And you would sleep badly, because you have chosen to live under the one part of the ceiling that is known to open. Lineae are the tidy version of Europa's damage. They are cracks. Cracks are understandable. There is another kind of terrain up there, and it is what happens when the ceiling stops cracking and simply comes apart. In 1996, Galileo sent home a picture that stopped the meeting. The tidy cracked egg pattern ran across the frame and then it ended. Where it ended, the terrain turned into wreckage. Slabs of ice the size of counties tilted at wrong angles, floating in a frozen brown mush. Some had rotated. Some had drifted a mile from where they belonged. And you could take those slabs and mentally slide them back together, like puzzle pieces, and the old cracks lined up perfectly across the joins. Somebody named it Chaos Terrain. The name stuck because nothing better existed. The biggest example is called Connemara, and it covers an area about the size of Connecticut. Picture a frozen lake in spring. The surface breaks into plates, the plates drift and turn in the slush, and then the whole thing freezes solid overnight, locking the mess in place forever. That is what the photograph looks like, on a moon, at 300 degrees below zero, in slabs 6 miles across. The obvious reading is the terrifying one. The ceiling melted through. Something warm arrived from below. The ice thinned. It broke into rafts. The rafts floated on liquid water, drifted, spun, and then the cold came back and welded them in place. If that is right, the ocean itself reached the surface of Europa, and it did it recently, and it will do it again. Chaos covers a serious fraction of the moon. There is a quieter explanation. Some scientists argue nothing melted all the way through. Instead, warm ice rises from deep in the shell in slow blobs, the way wax rises in a lava lamp, and when a blob reaches the underside of the surface, it makes a lake trapped inside the ice, miles down, with a solid roof still on top. The lake churns, the ice above it collapses into it, and you get the wreckage without ever opening a hole. Both stories fit the picture. Nobody has settled it. It is one of the sharpest arguments in the field, and it decides everything, because the two versions describe completely different worlds. One has an ocean that touches the sky. The other has an ocean sealed in a box. The chemistry leans toward the ocean. Chaos regions carry a fingerprint. Telescopes looking at those exact patches found ordinary salt, sodium chloride, table salt, chewed up by radiation. Salt does not come from the sky. It comes from water that has been sitting on rock. Finding it in the wreckage says the wreckage came from below. For a colonist, chaos terrain is the most valuable real estate on the moon and the worst place to build. Valuable, because if the ocean has ever reached the surface, this is where. Your shortest route between the water and the sky runs through here. Anything alive down there left evidence up here, frozen, waiting. Terrible, because your ceiling has a history of collapsing into your ocean. Nobody knows how often. Nobody knows how fast. The last event in Connemara might have been 1 million years ago, or 10 million. The instruments are not good enough to tell you whether you have a warning or a shrug. Europa Clipper carries radar that will look inside the shell and settle it, starting in 2031. Until then, look up. Because the ceiling is doing something else, something almost gentle, and it happens every single day. It is snowing. Upward. Take a bottle of very pure water and put it in the freezer. Wait. Watch the clock. The temperature drops past freezing, and the water sits there still liquid because ice needs something to grab onto. A speck of dust. a scratch, a bubble. Perfectly clean water has none of that, so it just gets colder and stays wet, holding its breath. Now take the bottle out and slam it on the table. The whole thing turns to slush in front of your eyes. One shock, and the water crystallizes all at once. That is happening under Europa's ice right now. Glaciologists call the result frazzle ice. On Earth you find it under the Antarctic shelves, in the water pressed against the underside of the shelf. Supercooled water, turbulent water, and suddenly a cloud of tiny ice crystals appears out of nowhere. And ice is lighter than water. So the crystals rise. They drift upward through the black, slowly at first, then faster, gathering into a haze, then a flurry, then a storm, all of it going the wrong way. They collect against the ceiling and stick. Layer after layer, they build the underside of the ice shell from beneath. Snow falling up onto a sky. In 2022, a team at the University of Texas worked out how much of Europa's shell could be built this way. Their answer changed the whole picture. Frazzle probably fills in the gaps, where a crack opens in the shell, where the ice suddenly thins, where a piece of chaos terrain breaks apart. Frazzle rushes in and heals it from underneath. The scars on Europa's face get stitched shut by snow rising out of the dark. Live down there, and this is your weather. You get one kind. It never rains, it never blows, and the temperature never moves. But somewhere near your habitat, on a schedule set by currents you cannot see, the water fills with white and the ceiling starts collecting a coat. It coats everything else too. Your antenna, your cables, your windows. Your habitat is stuck to the ceiling, so anything landing on the ceiling lands on you. Every surface facing up, which on Europa means every surface, slowly grows a rind of ice. Scraping is a chore. Someone does it every week, floating outside in the dark with a heated blade, clearing frost off a submarine that is bolted upside down to the bottom of the world. And the storms bury things. Drop a marker on the ceiling and come back in a decade and it is gone, entombed, part of the shell. There is a joke waiting in there. On a world with no weather, the first thing you would complain about is the snow. But Frazzle is doing something far more important than being scenery, and the discovery caught everyone off guard. Because of how it forms, this snow leaves something behind, and what it leaves behind decides whether you can drink the ocean. Freeze a glass of salt water and taste the ice. It is almost fresh. Water is picky. When it crystallizes, it wants pure water molecules in the lattice, and it shoves the salt aside. The salt gets squeezed out into whatever liquid is left. This is why sea ice at the North Pole is drinkable, and why sailors on wooden ships melted it and lived. The ocean freezes and the ice comes out clean while the salt gets left behind in the water. The trick works better when the freezing is slow, and worse when it is rushed. Ice that grows steadily downward off the bottom of a shelf, one layer at a time, still traps some salt. Glaciologists call it congelation ice, and it holds roughly 1/10 of the salt in the water that made it. Frazzle is different. Frazzle crystals form loose in open water, tiny, spinning, with nowhere to trap anything. The salt has an easy escape. Frazzle ice holds about 1/1000th of the salt of the water it came from. That is 100 times purer. The team that worked this out in 2022 realized what it meant. Europa's ice shell might be far cleaner than anybody assumed. Not made of frozen ocean, but of ocean that dropped its salt on the way in. Which hands a colony the answer to its most basic problem. You're floating in more water than Earth has, and none of it is drinkable. Europa's ocean is salty enough to matter. Pulling salt out of water costs enormous energy, and energy on Europa comes from a nuclear reactor you had to fly across the solar system. So you do not drink the ocean, you drink the sky, melt your ceiling. The ice above your head, if the Frazzle story holds, comes out nearly fresh. Point a heater at the roof, catch the water, filter it, and you have a supply that never runs out and costs you nothing but warmth you are making anyway. The single most expensive thing about living underwater becomes the easiest thing you do all day. Your ceiling is the well. That same purity matters to the scientists, in a way that runs deeper than plumbing. Europa Clipper carries radar built to see inside the shell. Radar hates salt. Salty ice is full of charged particles that swallow the signal and turn it to noise. Clean ice lets the pulse run deep and come back honest. If the shell is fresh, the radar could reach further than anyone dared to hope. It might find the lakes trapped in the ice, it might find the ocean ceiling itself, it might draw the first real cross-section of a world we have only ever seen from outside. If the shell is salty, the radar goes blind in the top mile and the mission gets much harder. We find out in 2031, and notice the shape of what just happened. The clean ice is clean because the salt went somewhere. It went down, all of it, for 4 billion years. Which means the water under your floor has been collecting the leftovers since before Earth had life, and its chemistry is the most important thing on this moon. There is a difference between salty and salty. The Dead Sea is salty. So is the Atlantic. So is the water dripping out of a magnesium mine. They will all make you spit, and they are chemically nothing alike, and the difference between them is the difference between a world with life and a world without. So which one is Europa? For 20 years, the smart money said magnesium sulfate. That is Epsom salt, the stuff people pour in a bathtub for sore muscles. Galileo's instruments looked at Europa's surface and saw something that fit, and models of rock reacting with water agreed. The picture settled. Europa's ocean was a bitter mineral broth, harsh and strange, wrong for anything we would recognise. Then somebody looked in a better place with a better eye. In 2019, a team pointed Hubble at Europa's chaos regions, the wrecked terrain where material from below reaches the top. They were hunting for a specific signature. Ordinary table salt, sodium chloride, does something peculiar when you blast it with radiation. It turns yellow. The crystal gets damaged and starts absorbing a particular shade of blue light, and the leftover colour you see is yellow. Europa's chaos regions are yellow. The signature was there, exactly where it should be, in exactly the places where the ocean surfaces. Table salt. The same thing in the shaker on your table. That single result rewrote the ocean. Sodium chloride means the water has been in long, patient contact with rock, dissolving it the way rivers dissolve continents. It means Europa's sea might be closer to ours than to a chemistry set. Nobody has thrown out magnesium sulfate. It is probably in there too, along with sulfur that Io is spitting into space and Europa is catching. The best guess today is an ocean that is mostly sodium chloride, with a mix of other things riding along. So bring a cup up from a sampling line and taste it. It would taste like the sea, colder than any water you have touched, flat with no life in it to make it smell of anything. And behind the salt, something sharper, something metallic that catches at the back of your throat. You would recognize it. That is the unsettling part. The first alien ocean humans ever drink from would taste like a mouthful of the Pacific. The saltiness matters for reasons beyond your tongue. Salty water carries electricity. Push a magnetic field through it, and the water pushes back with a field of its own. This is how we knew Europa had an ocean in the first place. Galileo flew past, felt a magnetic signature coming out of the moon, and the only thing that explains it is a large global conducting layer of salty liquid under the ice. The moon answered Jupiter's field, and the answer was water. Salt also decides the freezing point, which decides how thick your ceiling is, which decides everything. And salt in the ocean means salt on the surface, because the two are connected. Which is why Europa is not a white moon. It is streaked, stained, painted along every crack in shades of rust and brown, in a pattern that follows the wounds exactly. Those stains are the ocean's handwriting, and they have been trying to tell us something for 40 years. Europa should be white. It is filthy. Every crack on the moon is stained. Rust, brick, dried blood. A dirty orange-brown that bleeds outward from the seams for miles, fading as it goes, so the whole moon looks like a cracked plate somebody left tea in. For 40 years, that colour has been the most argued about paint job in the solar system. Here is why it matters. The stains follow the wounds. They sit inside the lineae, inside the chaos regions, inside every place where the ceiling has opened. Clean, bright ice sits everywhere else. The colour goes exactly where the inside of the moon comes out, so the stains are the ocean, dried on the surface. Now what makes them brown? Start with what happens when the sky hits salt. Europa's surface is a chemistry lab running at full speed, powered by the radiation that would kill you in a day. Those particles slam into the ice and break everything they touch. Water splits into hydrogen and oxygen. Oxygen recombines into hydrogen peroxide, the stuff in a brown bottle in your bathroom, and telescopes see it on Europa in real quantities. Salt crystals get their structure knocked out of shape and change colour. Sulphur, arriving as a steady rain from Io next door, cooks into compounds that run yellow and orange and red. Then the puzzle. Sulphur from Io lands on the whole moon. So why does the colour only show up on the cracks? The best answer is that both things are true at once. Material wells up from below, carrying salt and whatever else the ocean holds, and the radiation immediately gets to work on it. The sky and the sea meet at the seam and paint it, which turns Europa's face into something extraordinary. You do not need to drill to read this ocean. You do not need a submarine. The moon keeps squeezing its insides out onto its own surface and then holding them up to the light, and a telescope 400 million miles away can look at the colour and work out what is dissolved in a sea nobody has ever touched. Europa is a world that writes its own diary on its skin. There is a catch, and it is the reason Europa Clipper flies so close. Radiation ruins the evidence fast. Anything organic that reaches the surface gets shredded within days to weeks in the top layer. So the diary is written in disappearing ink. Look at old ice and you see the wreckage of chemistry, scrambled beyond reading. You have to catch it fresh. Which is why the mission targets the youngest terrain it can find, and why the instruments are built to sniff the thin haze of atoms floating just above the ice. Fly through that haze at 15 miles a second, and you are sampling the moon without landing on it. Now put yourself back under the ice, and think about what the stains promise. They promise the pipe is open. They promise that whatever your habitat floats in has, at some point, made the trip up 18 miles and out into the sky. They promise a connection between the water and the world, and a connection running upward can run downward too. Because the same radiation that ruins the diary is also building something. Every second it is manufacturing the one substance your ocean needs more than anything else. The question is how much, and for 4 decades the guesses were off by a factor of 1,000. Almost every animal on Earth runs on the same deal. You breathe in oxygen, you use it to pull energy out of food, the way a fire pulls energy out of wood. It is the most powerful chemical trick life has ever found, and it is why anything bigger than a slime layer exists. And there is no oxygen on Europa. There is no photosynthesis. There is no sunlight in the water to run it. So an ocean under 18 miles of ice should be a dead, airless swamp. Except Europa has a factory on the roof. Jupiter's radiation slams into the surface ice and cracks water molecules apart. Hydrogen is the lightest thing in the universe, and it escapes into space almost instantly. Oxygen is heavier. It hangs around. Some of it drifts into a thin haze above the moon. Some of it gets locked into the ice itself. Europa is manufacturing breathable oxygen with nothing but radiation and time. So how much? For 30 years, nobody could say. The estimates ran from a few pounds a second to more than 2,000 pounds a second. That is a spread of 1,000 to 1. Imagine asking how much your car weighs and being told anywhere between 2 pounds and 2 tons. That is where the science sat. Then Juno flew through the haze. On the 29th of September, 2022, the spacecraft passed 220 miles above Europa and used an instrument built to count particles in Jupiter's auroras. It caught hydrogen and oxygen ions being stripped off the moon and swept away by the magnetic field. Count the ions, do the arithmetic, get the rate. The answer came back in 2024, 26 pounds of oxygen every second, which works out to about 1,000 tons a day. Say it the friendly way and it sounds glorious. 1,000 tons a day is enough oxygen to keep 1 million people breathing for 24 hours. Europa is running a life support system for a city that does not exist. Now say it the honest way. That is the output for an entire moon, and Europa's ocean holds more than twice the water of Earth. Pour 1,000 tons of oxygen into a body of water that size, and you're salting the Pacific with a teaspoon. Worse, the number came in at the low end. The optimist had hoped for hundreds of times more. The measurement chose the pessimistic half of the range and closed the argument. For a colony, None of this is a problem. You make your own air by running electricity through water, and you have more water than any civilization in history. Breathing is the easiest thing you will do on Europa. For life in the ocean, it is everything. But there is a step in this chain that nobody has ever seen work, and it may be the place where the whole dream dies. The oxygen is on top, the ocean is at the bottom, and between them sits 18 miles. Fill a bottle with water, screw the cap on, leave it 100 years, the water inside will still be there, the air outside will still be there, and they will have nothing to do with each other forever, because a wall sits between them. That is the nightmare version of Europa. The oxygen gets made on the surface, and it stays on the surface, and the ocean never learns it exists. Everything depends on a delivery system. And here is the trouble. Nobody has ever watched one work. There are 3 candidates. The first is convection. Ice, given enough thickness and enough heat from below, starts to flow, slowly. Warm ice rises in slow columns, cold ice sinks, and the whole shell turns over like water in a pot. Give that engine 10 million years, and it could drag surface material down and ocean material up. The second is subduction. Europa may run ice tectonics, one plate sliding under another and carrying its cargo down. The third is the cracks. A fracture opens, the ocean pushes into it, and the connection is direct. Every one of these is a model, a drawing, a thing that happens in a computer. Then the Juno measurement arrived and made all 3 harder. 18 miles of ice means the trip is long, and the same data showed the flaws in the upper ice reach only hundreds of feet down before they stop, which turns the cracks on the surface into potholes rather than tunnels. The team said it out loud in their paper. On their own, the fractures we see are unlikely to carry anything to the ocean. So convection has to do the work, and convection is slow. Now here is the turn nobody sees coming. Suppose the delivery system works too well. Oxygen is not gentle. Oxygen is a wrecking ball. It rips electrons off everything it touches, and that is exactly why life uses it. Free oxygen in water, with nothing around to consume it, builds up into a chemical that burns anything organic on contact. On Earth, our oxygen is balanced. Life makes it and life eats it, and the two have been holding hands for 2 billion years. Europa has the making with nothing doing the eating. Some scientists ran that forward and found something bleak. 4 billion years of radiation, feeding oxygen into a sea with no plants, no animals, no bacteria to burn it off, could push the water past the point where any chemistry we recognise can survive. You get an ocean that is chemically on fire, a sterilizer the size of a planet, which leaves Europa balanced on a knife. Too little oxygen and the ocean starves, too much and the ocean burns. Life needs a window, and nobody knows if Europa's window is open. The strange thing is that we found a clue, and it came from a telescope that was not even looking for it, because the ocean has been sending us mail. And in 2023, we finally opened it and found the one ingredient that matters more than air. You're made of carbon. Every protein, every strand of your DNA, every cell wall. Carbon is the only atom that bonds to itself in long chains and rings and branches without falling apart, which means carbon is the only atom that can build a machine complicated enough to be alive. Water gets all the headlines. Carbon does the work. So the question about Europa was never only about water. We knew about the water. The question was whether that ocean had anything in it worth calling chemistry. In 2022, the James Webb Space Telescope opened its eye. In 2023, 2 teams pointed it at Europa. They were looking for carbon dioxide. Carbon dioxide had turned up on Europa's surface before, back in the Galileo days, and it meant nothing. Comets deliver carbon dioxide to everything in the solar system. Radiation cooks it out of dust. Could have come from anywhere. Webb could do something Galileo never could. It could make a map. If the carbon dioxide came from space, it should be smeared evenly across the moon, the way dust settles on a shelf. The map came back lopsided. The carbon dioxide clumped. It piled up in one region, a patch called Terra Regio, and that patch happens to be one of the youngest, most torn-up pieces of chaos terrain on the moon. It is the same region where the yellow salt signature shows up. It is a place where the inside of Europa has recently come out. Comets do not aim. The carbon came from below, which means Europa's ocean holds carbon, not delivered, not painted on from space. dissolved in the water, riding up through a break in the ceiling, freezing on the surface, waiting for somebody with a good enough telescope to notice. The teams were careful. There is a version where ocean chemicals reach the surface as something else, and radiation turns them into carbon dioxide up there. Even that version requires the carbon to have come from the ocean. Either way, the ledger changed. Line up what Europa now has. Water, more than twice Earth's supply, liquid and salty and in contact with rock. Energy, poured in for 4 billion years by a planet that will not stop squeezing. Carbon, dissolved in the sea. Oxygen, manufactured overhead. Sodium chloride, which says the water has been dissolving stone for ages. That is the checklist. Every ingredient we say life requires we have now found on a moon smaller than ours, in the dark, 5 times further from the sun than the ground under your feet. Nobody has found life. Finding the ingredients in a kitchen tells you nothing about whether anyone cooked. But it moves Europa from a curiosity to the best address in the solar system, and it moves the question from could there be to why would there not be? And it puts a very hard problem in front of any human who wants to live there, because a colony has to eat. Down there, sunlight is worthless, so you would have to learn to run a food chain the way Earth's deepest creatures do, and the way we found out about that is one of the great accidents in the history of science. In February of 1977, a small submarine called Alvin dropped through 8,000 feet of black water off the Galapagos Islands. The crew were geologists. They were hunting for hot springs on the seafloor. Nobody on board was thinking about biology because everybody already knew the answer to biology. The deep ocean is a desert. Sunlight stops a few hundred feet down. No sunlight means no plants. No plants means no food. The deep sea survives on scraps drifting down from above, and there are never many scraps. They found the hot springs. Then their light swung sideways and the crew stopped talking. There were clams the size of dinner plates. There were crabs. And standing over all of it, packed together in forests, were tubes taller than a person with blood-red plumes waving out of the top. Thousands of them. A city, at the bottom of the world in total darkness, in water hot enough to melt their instruments a few feet away. The submarine had no biological sample containers on board. They had not thought to bring any. They stuffed a creature into a jar of vodka from someone's locker and brought it up. The tube worms had no mouth, no stomach, no gut at all. What they had inside their bodies was bacteria, and those bacteria were doing something that broke the rule everyone had learned in school. They were taking hydrogen sulfide, the poison gas coming out of the vent, and pulling energy straight out of the chemical bonds. No sunlight anywhere in the chain. They were building sugar out of rock breath. We call it chemosynthesis. And in one afternoon it doubled the number of places life could exist. Because photosynthesis needs a star, chemosynthesis needs water, rock and heat, which are exactly the 3 things Europa is suspected of having. 60 miles below the ceiling you would call home. Every vent on Earth is a small island. Life clusters on it, thick and loud and strange, and 100 feet away the seafloor is empty again. If Europa's floor has vents, Europa's life would be islands too. Scattered oases in 100 million square miles of nothing, each one glowing with chemistry, each one alone. For a colonist, this is the whole business plan. You cannot ship food from Earth forever. A supply run takes 6 years one way and costs a fortune, and if it fails, everyone starves in the dark. A colony that eats Earth's food is a colony with an expiry date. So you farm. And farming on Europa means either building a fake sun in a room, or learning the trick the tube worms learned, and growing your food on chemistry pulled from a moon. Both are being studied. Neither has ever been done. And the first one, the one that sounds easy, turns out to be the single largest thing you would have to build. Everything you have ever eaten was once sunlight. Bread was sunlight that a wheat plant caught. Steak was sunlight that a cow ate through grass. The sun soaked into a leaf, and the leaf became a chain, and at the end of the chain is your lunch. Every calorie in your body arrived from a star 93 million miles away for free. On Europa, you have to pay for it. Start with the arithmetic. A person needs roughly 2,000 calories a day. Plants are terrible at converting light into food, wasting the vast majority of what falls on them. To feed one adult from crops under lamps, you need somewhere around 300 square feet of growing area lit around the clock. For 100 people, That is a warehouse. Now find the electricity. Solar panels are a joke at Jupiter. Sunlight arrives at 1/25th of Earth's strength, and Europa Clipper carries solar arrays that span a basketball court to squeeze out enough power to run a few instruments. Nothing that thin will run a farm. And you're under 18 miles of ice anyway, where no photon has ever been. So a Europa colony is a nuclear colony. It cannot be anything else. A reactor flown across the solar system sitting inside a moon burning for decades, and the single largest consumer of that power is not heat, and it is not air. It is the lights over the lettuce. Then find the soil. There is none. Europa has ice, salt water, and rock 60 miles down that you cannot reach. There is no dirt in the accessible parts of this world, and there never has been. So you grow without it. Roots hanging in the open, with a nutrient mist sprayed on them, or sitting in trays of water dosed with exactly the right chemistry. It works. Growers on Earth do it now. It also means every atom of nitrogen, phosphorus, and potassium your plants eat has to come from somewhere, and Europa does not sell fertilizer, which forces the ugliest rule of the colony. Nothing leaves the loop, ever. Every scrap of food waste, every dead plant, every bit of human waste goes back into the system to be broken down and fed to the next crop. The nitrogen in your body tonight was in a tomato last month, and will be in a tomato again. A closed farm is a closed conversation between you and your dinner, running in a circle forever. Miss the balance and the whole thing collapses. In the 1990s, a seal test habitat in the Arizona desert ran into trouble, when the oxygen quietly vanished into the concrete walls and the crew ended up gasping and hungry in a building on Earth with an unlocked door. Europa has no unlocked door. Low gravity might help. Plants push roots down by feeling gravity, and nobody knows what a wheat stalk does at 1/8. It may grow tall and lazy. It may not know which way to point. Nobody has tested it, because nobody has ever farmed anywhere except a planet. There is a shortcut, and it is sitting right outside your window. If Europa's seafloor has hot cracks in it, then the ocean is already growing food. You would only have to find it. And that is where the last 2 years have gone very badly wrong. Saturn has a moon that already answered this question, and it answered yes. Enceladus is small. You could hide it inside Texas. It is covered in ice and it has an ocean and it should be a frozen pebble. And in 2005, the Cassini spacecraft caught it, doing something ridiculous. Jets of water were firing out of cracks near its south pole and into space, hundreds of miles high, feeding a ring around Saturn. So Cassini flew through the spray, repeatedly, at thousands of miles an hour. In the samples buried among the ice grains were tiny specks of silica. That sounds boring. It is a bombshell. Silica grains of that exact size only form one way we know of. Water has to be sitting on a rock at temperatures above about 200 degrees Fahrenheit, dissolving it, then cooling fast, hot water, on a rock floor, inside a moon the size of Arizona. Cassini also found hydrogen and methane in the plume. Hydrogen is a vent breath. On Earth, hydrogen and carbon dioxide together are the exact fuel that the deepest, oldest, simplest organisms on our planet live on. Enceladus has hydrothermal vents. That is as close to certain as this field gets, which set the expectation for Europa, and the expectation was enormous. Europa is bigger. Europa gets squeezed harder. Europa's ocean is vastly larger. If a moon the size of a state can run vents, then surely a moon the size of our own, wrapped around a rocky heart, would be roaring. There is a beautiful mechanism for it too. Certain rocks, when water gets into them, chemically drink it. They swell and they change, and the reaction gives off heat all by itself, no volcano required. It also releases hydrogen straight into the water. Whole regions of Earth's seafloor do this, building strange white towers that stand hundreds of feet tall and leak warm alkaline fluid, and life swarms them. Run that on Europa and the seafloor lights up. So teams went looking for the proof. They looked for plumes. Hubble thought it saw water venting off Europa's south pole in 2012, and again later. It was faint, at the ragged edge of what the telescope could do, and it never quite repeated. Webb went hunting for those plumes with an instrument far more sensitive. It found nothing. Nothing at all. Multiple attempts, and the sky over Europa stayed clean. That absence lands hard. Enceladus wears its ocean on the outside, spraying it into space where anyone can taste it. Europa keeps its mouth shut. And then, over the last 2 years, a group of scientists sat down and asked a question nobody had bothered to ask. They stopped assuming Europa's seafloor could crack. They ran the numbers on whether it actually can. And the answer they got may be the worst news this moon has ever received. A vent is a hole. That obvious fact is the thing everyone skipped past. For water to come out of a seafloor hot, the floor has to be broken. You need a crack. You need it to run deep thousands of feet down into the rock so water can get in, reach the heat and come back up. No crack, no vent, however hot the inside is. So a group of scientists asked what breaks Europa's floor. They went through every candidate, the tidal squeezing from Jupiter, the slow shrinking of a cooling body, churning in the rocky mantle, the swelling of rock as it drinks water. They took each force, calculated how hard it pushes on the seafloor, and compared it against how much force it takes to make stone slip. Every single one came up short. Not close. The tidal stress at the depth you would need, about 3,000 feet down into the rock, came out roughly 12 times too weak to break anything. Even along old fractures that were already there and already weakened, the rock holds. The lead author put the conclusion in about as blunt a form as this field allows. Send a submarine down to Europa's floor, he said, and we predict you would find no new fractures, no volcanoes, and no plumes of hot water. Then look at the rest of the ledger from the last 2 years. The oxygen came in at the low end of every estimate. The ice came in at 18 miles, far thicker than the optimists wanted. The surface cracks turned out to be shallow and unlikely to carry anything down. The plume hunt came up empty, and now the seafloor may be a slab that has not moved in 1 billion years, every result in the same direction. The reason Europa can be this way is the same reason it was ever interesting. Europa is small. Its rocky heart is a fraction of Earth's. Radioactive elements deep inside a planet keep it warm from within, and there are only so many of those. Earth is big enough to still be burning. Europa's internal fire may have gone out ages ago. That leaves the tides, and the tides do their work in the ice. Up high, where the shell is soft and bends. By the time that energy reaches down through 100 miles of water to the stone, there is barely anything left of it, which produces a picture nobody wants. An ocean, enormous, ancient, salty, holding carbon, sitting on a floor of cold, dead, unbroken rock, warm enough to stay liquid, still enough to be a refrigerator. Chemistry needs a mixer. Energy has to come in, and something has to keep stirring it, or the reactions run once, reach a stalemate, and stop. A sealed jar of the right ingredients does not become alive. It becomes a jar. Europa might be the largest, most beautiful, most carefully preserved jar in the solar system. These are models, and models have been wrong before. The authors admit that over billions of years the rock may have weakened enough for shallow cracking. And there is one fact still standing. One thing about Europa that no other ocean moon can claim, and it is the reason nobody has given up. Everything in your body came out of a rock. The iron in your blood, the calcium in your teeth, the phosphorus holding your DNA together. Water on its own is a solvent with nothing to dissolve. Life needs a supply cabinet, and the cabinet is stone. So the question that decides whether an ocean is a habitat or a puddle is simple. Does the water touch rock? For most of the ocean worlds, the answer is no. Here is the reason, and it is one of the strangest facts in chemistry. Ice floats. Everyone knows that. Freeze water and it expands and the ice sits on top, which is why lakes freeze from the surface down and fish survive the winter. Squeeze water hard enough and it stops behaving. Under enormous pressure, water molecules pack into different arrangements, and those arrangements are heavier than the liquid. You get ice that sinks. You get ice that stays solid at temperatures well above boiling. It is called high-pressure ice, and it is one of the most common substances in the outer solar system. Now look at Ganymede, the biggest moon in the solar system, sitting one door out from Europa. It has an ocean many times deeper than Europa's, and the water at the bottom is under such crushing pressure that it freezes solid. From below, into a layer of high-pressure ice hundreds of miles thick. Ganymede's ocean sits on a floor of ice, on top of rock it will never reach. Same story on Callisto, same problem at Titan. They are oceans in bottles, beautiful, huge, and sealed away from the one thing they need. Whatever minerals are down in that rock stay down there, locked behind a wall of ice that will never melt. Europa is different, and it is different because it is shallow. Europa's ocean runs 40 to 100 miles deep. That is deep beyond anything on Earth. In this business, it is nothing. The pressure at Europa's floor stays under the line where high-pressure ice can form, which means the water goes all the way down and lands on stone. Real rock, silicate rock, the same family as the ground under your house, wrapped around an iron core, and the water has been in contact with it for 4.5 billion years, dissolving, leaching, taking what it needs. That is what the sodium chloride is telling us. That is why Europa's salt looks like Earth's salt instead of a mineral bath. Table salt is the signature of water that has been grinding on rock for a very long time. So even with a floor that never cracks, Europa keeps the thing that matters most. A dead floor still leaks. Rock in contact with water gives up its minerals slowly, patiently, without any heat at all. It is a slower kitchen. It is still a kitchen. Europa may be the only large ocean in the solar system where water and stone are actually touching, and that ocean is not still. It never has been. Something is moving down there, in enormous slow shapes, and it obeys rules that have nothing to do with wind. Every current on Earth starts with the sun. Sunlight heats the tropics and leaves the poles cold, and that difference drives the wind, and the wind drags the surface of the sea, and the sea starts to turn. The Gulf Stream exists because a star is shining on a spinning ball. Take the sun away, take the wind away, put a lid on the whole thing. What moves? Europa answers with something enormous. The engine down there runs on two things. The first is heat from below, whatever is left of it, warming the water at the bottom so it rises. The second is the ceiling. The ice is melting in some places and freezing in others, and freezing throws salt out into the water beneath it. Salty water is heavy. It sinks. Fresh melting makes light water that climbs. So Europa's ocean turns over, driven by its own roof. Then the spin gets involved, and this is where it becomes alien. Europa rotates once every 3.5 days. Slow, by Earth standards. But an ocean 100 miles deep with nothing to stop it feels that rotation in a way our thin ocean never does. Water that tries to move sideways gets deflected. Push it north, and it curves. It happens on Earth too, which is why hurricanes spiral. On Europa, the effect takes over completely. Simulations show the water organizing into columns, not currents flowing along the floor, standing pillars of water all lined up with the axis Europa spins on, each one moving as a single body from ceiling to floor. Some are wider than a state. They drift, they rearrange, they herd the heat and the salt into stripes. Picture the ocean sliced into a forest of invisible pipes, all standing at the same tilt, all quietly turning. Nothing on Earth looks like that, because our ocean is a puddle by comparison. The columns matter for a hard reason. They decide where things go. Whatever chemistry the floor produces, and whatever the ceiling drops gets sorted and carried by that structure. Life, if it exists, would be distributed by it, and every model shows the flow pushing hardest at low latitudes and behaving differently near the poles, which means Europa's ocean probably has climates, an ocean with regions, in the dark, under a lid. Now try living in it. Your habitat is bolted to the ceiling, so you are fine. Everything else you own is at the mercy of a river you cannot see and did not expect. Drop a probe and it does not go down. It goes somewhere. Lose a submarine and the search area is 100 miles thick. You would map those currents the way sailors mapped trade winds, over generations, by losing things and noticing where they turn up. And that is the whole problem with Europa. It is a world you have to explore blind. Your eyes are useless down there. Radio dies in salt water within a few feet. Your instruments are deaf and mute in the dark, except for one. There is exactly one sense that works in that ocean, and it works better there than anywhere in the solar system. In 1944, a scientist dropped a small explosive charge into the Atlantic and listened for it 2,000 miles away. He heard it. The ocean had a secret. At a certain depth, sound gets trapped. Pressure and temperature bend the sound waves back toward the middle of a layer, so instead of spreading out and dying, the sound is caught in a channel and runs and runs across an ocean basin for hours, losing almost nothing. That channel is why whales can call to each other from opposite ends of a sea. A blue whale sings, and something 2,000 miles away hears it, and the water in between carries the message like a wire. Sound in water travels about 4 times faster than in air, roughly a mile every second. And unlike light, which drowns in the first few hundred feet, sound does not care about darkness at all. Now put that in Europa. You have 100 miles of water wrapped without a break around an entire moon, with a hard ice ceiling on top and rock at the bottom. 2 reflective walls and 100 miles of clear liquid between them. It is a channel that never ends and never hits a coastline because Europa has no coastlines. A sound made in Europa's ocean might go all the way around the moon. You could shout and wait and hear yourself come back from the other side. For a colony, that changes everything. Radio is dead in salt water. Every submarine on Earth already knows this, which is why they talk in pings instead of words. On Europa, sound becomes your radio, your radar, your telephone, your map, and your alarm system, all at once. Fill the ocean with listening posts and you get a nervous system for a world. You would hear your own ceiling breaking overhead. You would hear ice carving on the far side of the moon. You would hear a submarine's engine 2,000 miles away as a whisper on a hydrophone. You would hear the shell heave and settle every 3.5 days like a heartbeat, and you would hear the floor. That is the real prize. Send a sound down and listen for the echo, and you learn how deep the water is and what the bottom is made of. Do it from 1,000 places and you draw the first map of Europa's seafloor, a world under a world sketched entirely in echoes. If there is anything hot down there, anything cracking, anything venting, it makes noise. Earthquakes make noise. Boiling makes noise. The ocean would tell you. Now think about the sound you did not plan for. Life on Earth is loud. Shrimp snap. Fish grunt. Whales sing. Nobody designed that. It happened because sound is the only thing that crosses an ocean, and anything living in the dark eventually learns to use it. If Europa's ocean has anything in it, and if that anything has been evolving in total darkness for 4 billion years with sound as the only sense worth having, then the first evidence would arrive the same way it does on Earth, as a noise, which raises a question about the dark itself. Because Europa is not entirely dark. Parts of it glow. There is a fish in the caves of Mexico that has no eyes. Its ancestors had them. They swam into a cave, generations passed, and the eyes went away. Not damaged, erased. The embryos still start building eyes, and then the body stops the work and covers them with skin, because an eye is expensive and useless in a place with no light. Nature does not keep what it does not use. Anything living in Europa's ocean has had 4 billion years in the dark. Whatever it is, it has never had an eye and never needed one. So Europa should be black. It is not. In 2020, a lab in California did something clever. They took ice, mixed it with the kinds of salts Europa is thought to have, dropped the temperature to Europan levels, and blasted it with an electron beam to imitate Jupiter's radiation. The ice lit up. It glowed. A steady, eerie shine coming out of the ice itself as the radiation punched into it, and the ice threw the energy back out as light. Then the strange part. The colour depended on the salt. Table salt glowed one shade, Epsom salt glowed another, ordinary water ice glowed brightest of all, which means Europa's night side is shining right now faintly in the dark, and the colour of that shine is a readout of what is dissolved in the ice. Nobody has ever seen it. It is far too faint next to sunlight, and no spacecraft has ever looked at Europa's night side with the right instrument at the right distance. Europa Clipper might. A moon that glows in the dark, in colours that tell you what its ocean is made of. Down under the ice, though, none of that reaches you. Your world is genuinely black and the human animal was never built for it. Take the light away from a person and things go wrong quickly. Volunteers in dark rooms start to see things that are not there within days. The brain is a machine that expects a picture, and if you stop giving it one, it makes one up. So a colony blazes. Every room, every corridor lit hard, because the alternative eats people. And step outside the habitat into the ocean, and your lamp becomes the only light for 100 million square miles. A cone. 50 feet of visibility. Beyond it, nothing. The strangest possibility waits out there in that nothing. Because on Earth, in the deep sea, life solved this problem. Most animals below 3,000 feet make their own light. It is the most common form of communication on our planet, and almost nobody has ever seen it. If Europa has life, and if that life ever needed to signal, the first alien anyone meets might introduce itself by lighting up, which is when the real danger begins, and it comes from us. There is a bacterium on Earth that shrugs off radiation, blast it with a dose thousands of times what it takes to kill a person, and it survives. Its DNA gets torn into hundreds of pieces, and then, over a few hours, it collects the fragments and reassembles them in the right order, like a shredded book putting itself back together. Scientists found it in a can of meat that had been sterilized with radiation and spoiled anyway. There are microbes that live in nuclear reactor cooling water. There are microbes that survive years bolted to the outside of a space station, in vacuum, in raw sunlight, at temperatures that swing hundreds of degrees. There are microbes frozen in Siberian permafrost for 500,000 years that wake up when you thaw them. Now put a spacecraft together in a clean room. The technicians wear suits. The parts get baked and wiped and scrubbed. And when engineers swab those rooms afterward, they find life. Not much, but something always survives the cleaning. And what survives is, by definition, the toughest thing in the building. You're not sending a sterile machine to Europa. You're sending a machine carrying the winners of a survival contest you accidentally ran. Most of them die on the trip. Radiation in space is brutal, and the surface of Europa is a sterilizer. Then you drill. The moment a cryobot melts down through 18 miles of ice, everything on it goes past the sterilizer and into the one place on Europa where nothing can be killed. Warm water, salt, carbon, darkness. An enormous supply of chemistry that has never been eaten by anybody. For a hardy Earth microbe, that is not a hostile alien environment. That is an all-you-can-eat buffet with no competition. We have a rehearsal for this, and it went badly. When the Russian team drilled to Lake Vostok, they kept the borehole open by filling it with thousands of tons of kerosene and antifreeze. When they finally broke through, lake water rushed up the hole straight through the chemicals. Samples came back with bacteria in them, and years later nobody can fully agree on which ones came from the lake and which came from the drill. We contaminated the most isolated water on our own planet, on our first try, with our best effort. Europa is 400 million miles away and we get one chance, and the loss would not be a spill. It would be an answer, erased. Suppose Europa has life, and it started on its own, separately from ours. That single fact would be the most important discovery in the history of our species. It would tell us that life is not a miracle, that it happens wherever the conditions allow, that the universe is full. Now suppose we get there first with a dirty drill, and Earth bacteria take root, and a century later a team finds life in Europa's ocean and reads its genes, and they are ours. We would have found the answer and destroyed the question in the same motion. This is why, in 2034, we're going to take a $5 billion spacecraft and deliberately smash it. On the 21st of September, 2003, engineers pointed the Galileo spacecraft at Jupiter and let go. It had been working for 14 years. It had discovered Europa's ocean, mapped the chaos terrain, found the magnetic signature that told us there was salt water under the ice, and returned nearly every picture of Europa we still use today. It was tired. Its main antenna had never opened properly, so it had spent its whole career whispering its data home through a backup at a painful trickle. Its fuel was gone. They flew it into Jupiter at over 100,000 miles an hour. It burned up in the clouds in seconds. They did it on purpose, and they did it for one reason. Galileo had launched with unsterilized parts. If it were left in orbit, its path would eventually drift, and one day, in 1,000 years or 10,000, it would hit something, and the something might be Europa. So they killed it while they still had control. Europa Clipper has the same appointment. Sometime around 2034, after its 50 passes are finished and its fuel is spent, it will be aimed at Ganymede and crashed into it. Ganymede is the safe choice, because its ocean is buried under 100 miles of ice and sealed under that layer of high-pressure ice that keeps water from ever touching rock. Nothing you drop on Ganymede's surface will ever reach anything alive. We build the most sophisticated planetary spacecraft ever flown, spend $5 billion and 20 years on it, and we plan its execution before we launch it. There is an entire discipline behind this, and it is one of the quieter, stranger achievements of our species. Rules written down, agreed to by nations, about how clean a machine must be depending on where it is going. Europa gets the strictest tier there is. The requirement is stated as a probability. The chance of contaminating that ocean has to stay below a number so small it reads like a joke. To meet it, planners trace the spacecraft's orbit forward for centuries. They model how the moons will tug it around. They calculate the odds of an accidental impact long after everyone in the room is dead. And if the odds creep up, the mission changes. Think about what that means. We are protecting a place we have never visited from ourselves on behalf of something we have no evidence exists at the cost of billions of dollars by international agreement, and we are doing it decades in advance. Whatever else you think about people, that is not a small thing. There is a mirror here, and it points back at any human who ever wants to live under that ice. A colony cannot be sterilized. A colony is 100 people, and every one of them is carrying trillions of bacteria, and they breathe and sweat and shed skin, and their habitat leaks, and their waste goes somewhere. The moment humans arrive, Europa's ocean has been introduced to Earth, which means the search has to finish before the settlers start. We look first, we answer the question, then we move in, and if you did move in, and the years passed, and you decided you wanted to go home, you would discover something nobody tells you. Getting out of Europa is far harder than getting in. Falling is easy. Everything falls. Getting a spacecraft from Earth to Jupiter is mostly a matter of aiming and waiting. Europa Clipper launched, borrowed a shove from Mars, borrowed another from Earth, and spent 5.5 years coasting 1.8 billion miles downhill toward a giant. Coming back is the opposite of that in every way. Jupiter has 300 times Earth's mass. It sits at the bottom of a gravity well so deep that everything nearby is stuck in it. Europa orbits at more than 30,000 miles an hour just to keep from falling in. To go home, you have to climb out of that hole, and the fuel it takes is enormous. Every pound you want to lift off Europa needs fuel. That fuel needs fuel to lift it. The math turns vicious fast, and it means you cannot bring a return rocket with you in any sensible way. So you make it there. Which is the one thing Europa is generous about. You are standing on the largest supply of rocket fuel in the solar system. Water is hydrogen and oxygen. Run electricity through it, and they come apart, and hydrogen and oxygen burned together are exactly what lifted the space shuttle. Your ocean is a fuel depot holding more propellant than Earth has water. It costs power, and lots of it, and the reactor is already running the farm. Then there is the climb. Before you touch a rocket, you have to go up 18 miles through the shell in an elevator running inside a shaft that a shifting moon has been trying to close since the day it was cut. Your launch pad sits on the surface, in the radiation, where 40 minutes is a long shift and a rocket has to be assembled by machines. You board with the countdown already running on your own body. And here is the part that closes the trap. The years you spent under the ice took your skeleton, 1/8 of a gravity for a decade, and your bones have quietly given back what they no longer needed. Your heart has shrunk to fit a world that asks nothing of it. Your spine has stretched. Now fly home to a planet that pulls 8 times harder than anything you have felt since you were young. Astronauts come back from 6 months in orbit and cannot stand up. They get carried out of the capsule, and they trained for hours every day, and they were only gone half a year. A person who grew up on Europa may never be able to visit Earth. Not for a holiday, not once. Their body would be an alien body built for a moon, and Earth would break it in an afternoon. Which is the quiet truth under every colony story ever told. The first generation chooses to go. The second generation does not choose anything. They are born 18 miles under an ice sheet, 400 million miles from the world their grandparents came from, and they look at photographs of blue sky the way you look at photographs of the Cretaceous. Europa would stop being an outpost and start being a homeland, which leaves the only thing worth going for: The reason anyone would spend the money, take the risk, and give up the sky. One cell. Everything alive on Earth is related. Every human, every whale, every mushroom, every tree, every bacterium in the soil under your feet. All of it runs on the same code, the same 4 letters of DNA, the same 20 amino acids out of the hundreds that chemistry allows, the same molecule for moving energy around inside a cell. That is not a coincidence. That is a family. Trace it back far enough, and every living thing on this planet meets at one point, 4 billion years ago, in one population of cells. Life on Earth happened once, then it never stopped. Which leaves us with a sample size of 1, and you cannot do science on 1. We have never known whether life is easy or whether life is a miracle. Whether it starts anywhere the ingredients sit together, or whether it happened here through some accident so unlikely that we are alone in 100 billion galaxies. Every telescope, every rover, every probe has been chasing that one question. And you cannot answer it with rocks, you cannot answer it with atmospheres, you need a second example. Now put a submarine on Europa's floor and find one cell. Just one. A smear on a rock, something so small you need a microscope to see it, doing nothing, in the cold, in the dark, as it has for 4 billion years. Read its chemistry. If it uses DNA, and if the code matches ours, then life travelled. Rocks blasted off Earth by asteroids have crossed the solar system before. We would be looking at cousins, and we would have learned that life spreads. If it uses DNA and the code is different, then 2 separate biologies invented the same molecule, and that would tell us that chemistry has favourites, that life follows rules, that anywhere the conditions repeat, so does the answer. And if it does not use DNA at all, if it runs on something we have never seen, in a shape nobody predicted, with a code that owes us nothing. Then life started twice, in one solar system, on 2 little worlds circling the same ordinary star, one of them a moon so small and so far out that we nearly did not bother to look. If it happened twice here, it happened everywhere. There are hundreds of billions of stars in this galaxy alone. There are more ice-covered worlds with hidden oceans out there than there are rocky planets in the warm zone we have spent a century obsessing over. Ocean moons may be the most common habitat in the universe, and every single one of them is hidden under a lid. The sky could be full and quiet because everybody lives indoors. One cell from Europa decides all of it. Right now, a spacecraft the size of a basketball court is coasting through the dark, 5 years from arrival. In December, it swings past Earth for a shove. In 2030, it reaches Jupiter. In 2031, it starts flying past that moon, close enough to taste the air. It cannot find life. It is not built for that. It is built to answer whether Europa could hold it. And then, some decade after, something will melt its way down through 18 miles of ice, and its lights will come on in water that has been waiting since before Earth had a fossil. And we will finally know whether we are alone, or whether we have had a neighbour this entire time, 3 years away, under the ice, in the dark, keeping quiet.